This is fundamental problem 8 from chapter 15. In this problem, the cart and the package have a mass of 20 kilograms and 5 kilograms respectively. If the cart has a smooth surface and it is initially at rest, while the velocity of the package is as shown, determine the final common velocity of the cart and the package after the impact. So this is from the impulse momentum chapter, so we're going to use equation 15-3. And this is section 15.3, in which the impulse should be equal to 0 if we pick our system correctly. So we want to check to make sure that the sum of the external forces acting on our system is equal to 0. So for this, we would choose our system to be the cart and the package together. If we look in the vertical direction, we have the force of gravity for the cart and the package together acting upward or acting downward, and the normal force from the floor on the cart acting upward. And it's possible that we also have a frictional force in the horizontal direction, but instead of looking at the cart with wheels, let's pretend instead that we have a sled on a frictionless surface. And normal force acting upwards, force of gravity acting downwards, and see what we have in this case, which is approximately the same as what we have here, and this will give us the solution in the back of the book. And later on in the course, we'll talk more about what you would do in this case here, where you have friction from the floor acting on the wheels of the cart. So if our system is the sled and the package together, we have no forces acting in the horizontal direction. Remember that equation 15-3 is a vector equation, so we can apply it in the vertical direction and also in the horizontal direction. And our system is the crate and the sled together. Initially, the cart is at rest and the package is moving with a speed which is shown here. We are only looking at the horizontal component, so if the magnitude of the velocity of the crate is 10 meters per second to begin with, using the triangle that they give us here, the horizontal component of the velocity is 8. So the crate has a mass of 5 kilograms and a horizontal component of velocity of 8. So using our impulse momentum relationship, the total momentum for the system initially, since the cart is at rest, is the mass of the crate times the velocity of the crate plus an impulse of 0 is equal to the final momentum. But afterwards, the cart and the crate are moving together. The total mass of the cart and the crate is 25 times the velocity of the cart and the crate moving together so they have the same velocity. And we can solve this to get the horizontal component of the velocity. That's 5 times 8, which is 40, divided by 25. That gives us 1.6 meters per second. And that is the solution to fundamental problem 15-8.